Imagine a massive gathering led by an infinite number of planets, stars, and moons, all of which work together exquisitely. Despite this, there is one particular section of this symphony that has puzzled astronomers for an extraordinarily long time. Exoplanets. Exoplanets are not unusual. They are planets outside our solar system, hidden deep within the Milky Way. You might be surprised to discover that among the enormous quantity of exoplanets in the universe are bodies so similar to Earth, so temptingly familiar yet mysterious, that they might be the celestial counterparts of our planet. We explore the fascinating field of Proxima B. Proxima Centauri b was found merely 4.2 light-years away. The James Webb Space Telescope, JWST, is accelerating our journey toward comprehending these cosmic mysteries, opening up a universe of possibilities. Picture, for a moment, your mind traveling across the vast astronomical size of our galaxy, the Milky Way, which contains billions of exoplanets. That's a number with 15 zeros. To put it in context, if each of these exoplanets were the size of a grain of sand, we wouldn't just fill the Grand Canyon. We'd create a Grand Canyon 2.0, extending to an enormous distance. Surprisingly, around 20% of these massive bodies are categorized as Earth-like in terms of geography and atmospheric composition. That suggests a 1 in 5 chance of finding a world identical to our own. And the story doesn't stop there. Orbiting these planets could be another quadrillion moons, natural satellites, like our own, caught in a gravitational dance with their homeworlds. If you've ever wanted to search for something life-sustaining in space, or something that threatens life as we know it, the universe offers an abundance of possibilities. The James Webb Space Telescope, the all-seeing sentinel, is our guide. Now that we've laid out the magnitude, the time has come to introduce the masterful artist, the James Webb Space Telescope. This celestial detective's expansive primary mirror, made up of reflective segments, exceeds even the most advanced optical equipment. Measuring 6.5 meters in diameter, it is 2.7 times larger than Hubble's primary mirror. Imagine it in detail. It can detect even the tiniest glint of a star many billions of light-years away, as well as the subtle details of orbiting planets. So what distinguishes the James Webb? Its revolutionary design is more than just its size. Equipped with cutting-edge instruments, including powerful spectrometers and sensors, these tools do much more than observe. They analyze and filter unprecedented light, emitted or reflected by massive celestial objects, to determine atmospheric conditions, density, composition, and even quantity. As cosmic investigators, they can determine whether a planet has water, organic elements, or even oxygen. The James Webb Telescope answers such questions, transforming itself from a passive observer into an analytical virtuoso. It's more than just the next step. Beyond Hubble, it constitutes a quantum leap. If Hubble amazed you, get ready for a genuine spectacle of radiant revelations. Proxima B, the closest Earth-like analog, deserves special attention in this cosmic performance. Since its intriguing discovery in 2016, the planet has become something of a Shakespearean epic complex, structured, puzzling, and utterly enthralling to astronomers and astrophysicists alike. What makes it so compelling? To begin with, Proxima B resides in our cosmic neighborhood, approximately 4.2 light-years from Earth. To put that into perspective, if you could defy the cosmic speed limit and travel at light speed, you'd arrive there in just over 4 years, about the length of time it takes your favorite TV show to finish a few seasons. But there's more to it than proximity. In a universe spanning over 93 billion light-years in diameter, finding a planet so close is like finding a gem in a mountain-shaped haystack, a gem that may hold the very secrets of life itself. Within the grand tapestry of the universe, Proxima B is a vital thread, one that might radically shift our understanding of existence and habitability beyond Earth. It's not just Proxima B's proximity that excites researchers, but the tantalizing signs that it might not only be Earth-like, It might be Earth 2.0. Proxima B orbits within the habitable zone of its star, the sweet spot where the temperature is just right for liquid water to exist. Think cascading waterfalls, winding streams, vast lakes, and perhaps even oceans as deep and mysterious as the Mariana Trench. But before we indulge in dreams of interstellar vacations, we must examine some of its defining features. For example, a single day on this curious exoplanet lasts about 11 Earth days. Picture dawns that stretch on slowly, afternoons that linger, and sunsets that bathe the horizon in surreal light. It would be a paradise for photographers, though idyllic. This slow rotation has significant implications for the environment and human adaptability. How would such rhythms of light and darkness affect our circadian cycles? Would we need to eat multiple times during a single day? Would we sleep once or multiple times? On such a mysterious planet, the rhythms of life would be both eerily familiar and shockingly alien. It's as though nature is revealing a puzzle within a puzzle, challenging our very definitions of what makes a world habitable. So, how do we collect accurate data about a planet we've never visited? The James Webb Space Telescope operates like a cosmic Swiss Army knife, which is more than just a telescope. It is a research lab floating in the void. Thanks to its ingenious design, astronomers don't merely look at planets, they investigate them. Using advanced spectrographs, they analyze light that originates from or reflects off these distant worlds. Every molecule absorbs or reflects light at specific wavelengths. By decoding those patterns, scientists can perform remote biopsies of exoplanet atmospheres, determining their density, pressure, and the presence of critical life-supporting elements like organic carbon compounds, water, or oxygen. Space science today is not just astronomy. It's forensic investigation on a cosmic scale. We're no longer waiting passively for signs of life. We're actively chasing atoms and molecules, tracing the very ingredients of these mysterious worlds. James Webb is more than just an eye in the sky. It's a laboratory, a specialist, and a one-instrument research team, all in one. Its tools enable us to turn theories about alien worlds into testable, data-backed hypotheses, reorganizing our comprehension of the potential to bear planets outside of our blue dot, an enigmatic techno-signature. Exactly when you believed you had removed the galaxy's most stunning layers, the narrative shifts drastically, resembling a science fiction thriller. Utilizing the James Webb Telescope, astronomers made an observation, a signal from a signal from Proxima B. It was a sign so remarkable it resonated throughout social media and academic halls. Dubbed an opportunity for a techno-signature, a transmission of electromagnetic energy bafflingly arranged, it might indicate the presence of a sophisticated civilization. Humanity held its breath in anticipation of reassurance that we are not the only ones, but the signal appeared as quickly as it vanished. No. Repeat. No follow up. It left behind not only a complete silence, but also a maze of unanswered questions and mounting theories. Was it only brief? An anomaly in space? A rare cosmic occurrence? Or was it a secret message sent with intent? A beacon from a distant planet. Only the absence of detection shrouded the mystery of Proxima B, sparking a raging debate. Was it a singular interest or a component of a larger, more complex story? Following this phase, artificial lighting. However, our odyssey is still not finished. The pen on our cosmic history still shines fresh, with upcoming chapters and new authors now. Researchers at Harvard are establishing a novel aspect of the search for intelligence from other planets. They intend to use the James Webb Telescope in new ways, transforming it into a kind of immense night vision apparatus. Their goal is to find artificial lighting that gives off a city-like glow on faraway worlds. Both on their dark sides and illuminated regions, we're discussing the possibility of detecting bright networks like urban landscapes and pulsating cities with civilization and its splendors spilling into the oceans of the planet as we keep deciphering the universe's mysteries. The search for life on other planets goes beyond Proxima B. Our extraordinary journey reaches farther into cosmic space, fueled by breakthroughs in technology and profound curiosity about our place in the universe. The future of exoplanet exploration already exists. Ongoing advancements in cosmology and space research have led to the discovery of numerous exoplanets with the potential to be habitable. Tools such as biosignatures, the James Webb Telescope, Earth-based observatories, and refined analysis have improved our ability to identify and examine these far-off places. A particularly appealing sector includes the search for exoplanets placed within the habitable zones of their stars, areas where liquid water exists, in so-called Goldilocks zones. The more we travel, greater our reach in space-based exploration. We are detectives at our best, examining the limits of the unknown universe, ripe for revelations that could reshape our perspectives on life. A sense of wonder endures, a constant excitement that the universe might conceal even more astonishing feats of nature and human advancement. The investigation of space is one of humanity's most immense intellectual endeavors. Fueled by curiosity, we go farther than ever. As we delve deeper into the cosmic void using instruments like the James Webb Telescope, our knowledge of the cosmos grows, and so does the possibility of uncovering new life forms. One of the most captivating aspects of exoplanetary science is the realization that we aren't merely discovering new worlds, we are revising the very definition of habitability. When we look beyond our own, we begin to wonder on what must life depend. Must it exist only in Earth-like conditions, or could it thrive in radically different environments? Could it survive on planets with extreme climates, toxic chemicals, or intense radiation? Or could life elsewhere take on entirely new appearances, shaped by biochemical processes that are hard for us to fathom? In recent years, the discovery of extremophiles organisms on Earth flourishing in scalding springs or near deep-sea vents has revolutionized our understanding of life's adaptability. These robust organisms demonstrate that life may still exist in places once deemed uninhabitable. Now, the possibility of locating extraterrestrial life appears more believable than ever. Furthermore, advances in machine learning and artificial intelligence are significantly raising our ability to analyze massive amounts of data collected from distant planets, spotting patterns that humans might overlook. With these tools, astronomers can now identify potential exoplanets with astonishing precision, narrowing the search for habitable worlds. Future space telescopes could bring us even closer to resolving one of humanity's most profound questions. Is it just us? The expedition continues. At the same time, the idea of technosignatures, artificial traces of advanced civilizations, has sparked renewed scientific discussion. What if we aren't merely looking for biomarkers, but also for evidence of intelligence? Could the light patterns from exoplanets be fabricated signals, deliberate signs from faraway civilizations? The recent discovery of an unidentified signal from Proxima reminds us that the universe may still contain the unexpected, challenging our assumptions about life's limits with its unmatched sensitivity and cutting-edge engineering. The James Webb Telescope could detect even the faintest hint of extraterrestrial intelligence. If it did, it would mark one of the greatest epochs in human history, the discovery of extraterrestrial life, whether microbial or intelligent, would transform our understanding of existence and force us to rethink everything we thought we knew about life, the universe, and ourselves. As we embark on this enormous journey of inquiry, we must also ask, where do we belong in this vast and ever-expanding cosmos? Should we endeavor to communicate with otherworldly civilizations? What responsibilities must we carry as we travel to other worlds? Space exploration continues to expand. In science, we search not only for signs of life on other planets, but also for the very essence of human nature. The future of space exploration promises excitement, revelation, and possibly world-altering discoveries. Here we are at the beginning of a brand new epic,